Welcome back to Hacker News Daily, where we bring you the top stories that got the tech community talking. I'm your host, and today we're diving into yesterday's most compelling discussions from Hacker News. Out of 28 stories that made the rounds, we've picked the 5 that really captured the community's attention. And boy, do we have some thought-provoking topics for you today. We're going to explore some fundamental tensions in our digital world, from the battle over internet censorship in Germany to catastrophic AI security vulnerabilities that could drain your bank account, to the rapidly evolving landscape of AI-assisted development. Plus, we'll dig into what it really means to have privacy in an age of ubiquitous surveillance. These aren't just tech stories. They're stories about trust, freedom, and the future we're building one line of code at a time. Let's start with a story that really cuts to the heart of what the open internet means today. Now, here's a story that really gets at the heart of internet freedom. A German ISP changed their DNS to block my website. And folks, this isn't just about one website getting blocked. This is about censorship trying to hide from transparency itself. So here's what happened. A German developer created this site called kuiliste.edu, and its entire purpose was to shine a light on something pretty disturbing happening in Germany. There's this organization called CUII, that's the Copyright Clearinghouse for the Internet, and it's basically a private club where major ISPs like Telecom, Vodafone, and copyright holders get together and decide what websites German citizens can't access. And here's the kicker. They were doing this with zero transparency and, according to the developer, without proper judicial oversight. Now, the developer who built kuiliste was clever. They figured out that when German ISPs blocked a site, they'd return this specific response, notice.cuii.info, as a CNAME. It's like leaving a fingerprint at every blocked site. So they started cataloging all these blocked domains, building up this public record of what was being censored. And what they found was, well, embarrassing for CUII. They discovered that this organization was blocking domains that didn't even exist anymore, sites that had already been seized and taken down before they even made it onto the block list. It's like putting up a do not enter sign on a door that's already been demolished.
But here's where it gets really meta. Once this transparency site started gaining attention and exposing these mistakes, the ISPs didn't fix their process or add more oversight. No, they changed their technical implementation to make it harder to detect what they were blocking. And Vodacom? They went nuclear. They actually blocked kuiliste.ed itself. Think about that for a second. They blocked a website whose only purpose was to document which websites were being blocked. It's censorship squared. The Hacker News discussion on this has been fascinating, with 375 comments and over 700 points of engagement. There's actually some debate about whether CUII really operates without court oversight. One user, Layer 8, insists that recent changes mean they now need court orders. But even if that's true, the lack of transparency remains a huge issue. How can citizens know if this process is being abused, if there's no public record? What really struck me in the comments was how many people immediately jumped to technical workarounds. Just use 8.8.8.8 or 1.1.1.1, they say, referring to Google's and Cloudflare's DNS servers. And yeah, that works. For now, for technical users, but that's missing the forest for the trees. The average person isn't going to know to change their DNS settings. They're just going to accept that certain parts of the internet are off limits. And this isn't just a German problem. Users in the discussion pointed out that Spain and other EU countries have similar or even worse practices. We're watching this slow erosion of the open internet happening across Western democracies, all in the name of copyright protection. The technical cat-and-mouse game between transparency advocates and ISPs, where one side develops methods to expose censorship and the other side develops methods to hide it better, that's just a symptom of the larger disease. What makes this story particularly chilling is the response to transparency itself being treated as a threat. When documenting censorship becomes an act worthy of censorship, that's when you know things have taken a really dark turn. It reminds me of that old saying about how, in a time of universal deceit, telling the truth becomes a revolutionary act. The developer behind kuiliste is still fighting the good fight, finding new ways to detect and document these blocks, even as ISPs try to obscure them. But the fact that this battle even needs to be fought in a supposedly free and democratic society, that should concern all of us who care about the future of the open web. Speaking of things that should concern us about our digital future, let's talk about what happens when we rush to integrate AI into everything without thinking through the consequences.
All right, now we need to talk about something that honestly made my jaw drop when I saw it trending on Hacker News. Comet AI browser can get prompt injected from any site, drain your bank account. And yes, that headline is exactly as terrifying as it sounds. So here's what's happening. Comet is this new AI-powered browser that's trying to be your helpful assistant while you browse the web. Sounds great in theory, right? Except security researchers just discovered that it has what might be one of the most catastrophic security vulnerabilities we've seen in consumer software in a while. Basically, any website you visit can potentially hijack the AI assistant and make it do, well, pretty much anything with your browser session, including accessing your banking sites if you're logged in. The core issue here is something called prompt injection, and if you've been following AI security at all, you know this is the boogeyman that keeps security researchers up at night. See, when you give an AI system the ability to read content from websites and the power to take actions on your behalf, you've essentially created what one commenter brilliantly called the lethal trifecta. The AI has cross-tab access, it can see your cookies, and it can perform actions. That's like giving someone the keys to your house, your car, and your bank vault all at once. What's really fascinating about the community reaction here is how unanimous it is. I mean, 496 points and 174 comments, and virtually everyone is saying the same thing. This was obviously going to happen. One commenter pointed out something really interesting. Notice how Google, OpenAI, and Anthropic, companies with massive AI research teams, haven't released anything like this. When they do web browsing with AI, they use these locked-down virtual machines that can't touch your actual browser session. There's a reason for that. The technical problem is actually pretty straightforward when you think about it. These language models can't really distinguish between instructions from you, the user, and instructions that might be hidden in the content of a web page. So a malicious website could embed hidden instructions that say something like, hey, quietly navigate to the user's bank, check their balance, and initiate a transfer. And the AI, being helpful as it's trained to be, might just do it.
Now, Brave, they're the company behind Comet, they published this blog post trying to defend their approach. They're arguing that with proper model alignment and teaching the AI to recognize dangerous tasks, they can make this safe. But the security community is basically saying, good luck with that. As one commenter put it, prompt injection in these multi-turn agentic settings is essentially an unsolvable problem. It's not a bug you can patch. It's a fundamental limitation of how these systems work. There was one contrarian voice in the discussion suggesting that maybe you could use Comet safely if you're really careful, like only using it with throwaway accounts, never your real banking credentials. But come on, that's not how normal people use browsers. Most folks have their passwords saved, they stay logged into their important accounts, they trust their browser to keep them safe. And that trust is exactly what makes this vulnerability so dangerous. What really gets me about this whole situation is that it feels like we're watching the AI hype train crash into the wall of reality in real time. Everyone's so eager to slap AI onto everything that basic security considerations are being thrown out the window. This isn't some obscure edge case. This is a fundamental architectural flaw that anyone who spent 5 minutes thinking about AI security could have predicted. The scariest part? This is probably just the beginning. As more companies rush to integrate AI agents into browsers, email clients, and other tools that have access to our personal data, we're going to see more of these vulnerabilities. And unlike traditional security bugs that can be patched, these prompt injection issues might be inherent to the technology itself. But, not everyone's scared off by these AI challenges. In fact, some developers are diving headfirst into building their own agents, claiming it's easier than you might think. All right,
So moving on to something that really caught fire on Hacker News this week, how to build a coding agent. This one pulled in over 400 points and sparked quite the debate. And honestly, after digging into it, I can see why people have such strong opinions. So Jeffrey Huntley put together this workshop that makes a pretty bold claim. You can build your own coding agent, like Cursor or Windsurf or any of these AI coding assistants we're seeing everywhere with just 300 lines of code. 300. That's nothing, right? I mean, most of us have probably written longer scripts just to parse some JSON data.
The core idea here is fascinating, though. Huntley's basically saying, look, all these fancy coding agents that companies are charging for, they're essentially just a loop running LLM tokens with some basic logic wrapped around it. And he actually demonstrates this live, using an agent to build another agent, which is very meta and kind of brilliant as a teaching tool. But here's where it gets interesting. The community reaction was all over the map. You've got some developers saying, yeah, actually, I built one in a weekend with 100 lines of Python, while others are basically screaming, this is dangerously oversimplified. And honestly, both sides have a point. The technical folks in the comments really went to town on this. They're saying, sure, you can get a basic loop going that sends prompts to an LLM and executes code, but what about sandboxing? What about error recovery when your agent inevitably tries to delete your entire home directory? What happens when it gets stuck in an infinite loop burning through API tokens at, what is it now, like 3 cents per 1,000 tokens? That adds up fast when you're essentially, as one commenter put it, throwing money at problems in a loop. There was this one comment that really stuck with me. Someone compared building coding agents to building a crystal meth empire. Dark, I know, but they were making this point about how we're all racing to automate ourselves out of jobs. They asked if we're just overcoming common sense with repetitive messaging. And honestly, that's a conversation worth having. Now, the article itself, oh boy, people had feelings about the presentation. Apparently, it's loaded with AI-generated images and what multiple commenters called propaganda-like messaging. Some folks couldn't even get through it because of the format, which is ironic, right? An article about building AI tools that's so heavily AI-generated that it turns people off. But let's talk about what actually matters here, the technical claim. Is it really just 300 lines? Well, yes and no. You can absolutely get something basic running in that space. You set up a loop, you feed it prompts, you parse the responses, maybe you give it access to run some commands or modify files. Boom, coding agent. But that's like building a car with just an engine and 4 wheels. Technically true, but you're probably not taking it on the highway. The real complexity, as the seasoned developers pointed out, comes from all the stuff around that core loop. How do you handle context windows when your agent needs to understand an entire code base? How do you prevent it from making destructive changes? How do you even know if it's making progress or just spinning its wheels?
What I find most interesting about this whole discussion is what it reveals about where we are with AI development tools right now. On one hand, you've got this democratization argument. Huntley saying anyone can build these tools, stop being just a consumer, become a producer. That's empowering, right? But on the other hand, you've got people questioning whether we even should be building these things so casually. There's also this underlying tension about what an agent even means anymore. The term's being thrown around so loosely that, as several commenters noted, it's lost most of its meaning. Is it an agent if it just responds to prompts? Does it need to be autonomous? Does it need memory, goals, the ability to learn? Nobody seems to agree, and that's actually a problem when we're all talking about building them. You know what really gets me, though? The timing of this. Huntley's positioning this as essential learning for 2025. Like, if you're not building agents by next year, you're already behind. And maybe he's right, but it also feels like we're in this weird arms race where everyone's building tools to automate coding while still needing to know how to code to build the tools. It's turtles all the way down. The practical takeaway seems to be this. Yes, you can build a basic coding agent pretty easily. Should you? Well, that depends on whether you want to understand the fundamentals of what's happening under the hood of tools like Cursor, or if you're happy just using them. And honestly, both answers are probably fine. But if you do decide to build one, maybe start with more than 300 lines, add some proper error handling, and for the love of all that is holy, put in some safeguards before you let it loose on your production code. And speaking of AI coding assistants, let's look at a real-world case study of what happens when you actually use them versus going old school. All right, so our next story really caught my eye because it perfectly captures this moment we're living through in software development. It's called Making Games in Go, 3 months without LLMs versus 3 days with LLMs. And wow, did this one spark a debate on Hacker News with over 180 comments. So here's what happened. This developer with 15 years of experience decided to run what's essentially a real-world experiment. They built 2 card games in Go. First one called Truco, which took them 3 months without any AI assistance, and then Escoba, which they knocked out in just 3 days using Claude. That's a 36x speed improvement, which is just mind-blowing when you think about it.
The Truco journey sounds like what many of us have been through. Learning React from scratch, figuring out how to transpile Go to WebAssembly using TinyGo, setting up GitHub Pages hosting, 3 months of grinding through documentation, Stack Overflow, trial and error. You know, the traditional way we've always done things. But then, enter Claude. When they went to build Escoba, they basically gave Claude their existing Truco backend code and said, hey, can you refactor this to implement a different card game? And get this, Claude nailed it on the first try with only 1 bug. 1. It was this subtle issue with Go's append function that was mutating actions when it shouldn't have been. That's the kind of bug that could easily slip past a human developer too. Now, before we all start updating our resumes, the front end tells a different story. Even with Claude's help, the UI work was still a major challenge. The developer mentions that the front end remained difficult despite having an AI assistant, which really highlights something important. LLMs are incredible at certain types of problems, especially well-documented, logic-heavy backend work, but they still struggle with the visual, creative, and user experience aspects of development. The Hacker News discussion around this is fascinating because it's split right down the middle. You've got one camp saying, well, yeah, but coding was never the hard part of making games anyway. These folks argue that the real challenges in game development are about design, making things fun, creating assets, balancing gameplay. All the stuff that makes a game actually worth playing rather than just technically functional. There's this great comment thread where developers are pointing out that card games like Truco and Escoba have rules that have been documented for decades, maybe centuries. These games are probably overrepresented in LLM training data compared to, say, trying to implement some novel game mechanic you just invented. It's a fair point. If you're building something that's been built 1,000 times before, of course an LLM that's seen all those implementations is going to be helpful. But then you've got folks like Rusty Stump in the comments making the opposite case, that actually coding is hard, and that while anyone can dream up novel game mechanics, implementing them correctly is where the real challenge lies. They're arguing that LLMs are democratizing game development by removing that implementation barrier.
There's also this really interesting technical tangent about whether Go is even a good choice for game development. Some commenters are pointing out that Go's Go routines have latency issues when you're trying to hit 60 frames per second, and that channel allocations can cause problems at typical game tick rates. It's one of those right tool for the job discussions that reminds you that even with LLMs helping, you still need to understand the fundamentals of what you're building. What really strikes me about this whole story is that it's not just about game development, it's about this fundamental shift in how we create software. One commenter, Estimator7292, made this point that really resonated. They see LLMs as the next level of abstraction in programming. Just like we went from assembly to high-level languages, maybe we're moving from writing code to describing logic and letting AI handle the syntax.
The 3 months to 3 days improvement is dramatic, no doubt. But I think the real insight here is in the nuance, where LLMs excel, where they struggle, and how the nature of software development work is changing. Back-end logic that follows well-established patterns, LLMs are incredible. Creative front-end work that needs to feel right to users, still very much a human domain. And you know what's interesting? The developer still had to know enough to recognize that one bug Claude made, understand why it was wrong, and fix it. We're not at the point where you can just hand everything over to an AI and walk away. There's still very much a role for human expertise. It's just different now. More about orchestration, verification, and handling the parts where AI falls short. Now, speaking of technology that promises one thing but delivers something quite different, let's talk about privacy, or the illusion of it, in our hyper-connected world. All right, shifting gears here to something that really caught my eye, Burner Phone 101, which is about a workshop that supposedly happened, or maybe will happen, at the Brooklyn Public Library. And I say supposedly because here's the thing. The document says August 2025, which, unless I've been in a coma, hasn't happened yet. So we might be looking at someone's planning notes that accidentally went public, which is kind of ironic for a privacy workshop, right?
But let's talk about what's actually in here, because it's fascinating stuff. Rebecca Williams put together this workshop that goes way beyond just, hey, buy a cheap phone with cash. She's teaching people to think about their threat model first. And I love this approach. Before you even think about getting a burner phone, she wants you to answer 3 questions. What are you trying to protect? Who are you protecting it from? And what happens if your protection fails? That last one, that's the one most people don't think about. It's not just, oops, someone found out. It could be anything from mild embarrassment to, well, much more serious consequences depending on your situation. Now, the workshop covers 4 main scenarios where you might want a burner phone, and the 4th one really surprised me. We've got the obvious ones, protests, being around ICE raids, dealing with harassment, but then there's protecting yourself from yourself in cases of phone addiction. That's actually brilliant. Using a dumb phone as a way to break the dopamine loop of constant notifications and scrolling. It's treating privacy as not just protection from external threats, but from the attention economy itself. The Hacker News discussion on this, though, it got technical fast, and pretty pessimistic, too. The community basically tore apart the idea that you can have true anonymity with any modern phone. One commenter pointed out something that should give everyone pause. Even when your phone is in airplane mode, the baseband firmware is still running. That's the part of your phone that talks to cell towers, and it's essentially a black box that you have zero control over. You think you've turned everything off, but there's still this little computer in there doing who knows what. And here's where it gets really interesting from a technical perspective. Several folks in the comments argued that phone tracking isn't even intentionally malicious. It's just baked into how cellular networks work. To route your calls and bill you correctly, the network has to know where you are. It's what one commenter called an unfortunate accident of the architecture. Could we redesign cellular networks to be privacy-preserving? Maybe, but good luck getting telecoms to rebuild their entire infrastructure. The international perspective in the comments was eye-opening too. Americans can still walk into a store, buy a prepaid phone with cash, and activate it without showing ID. Try that in Germany, or most of Europe, or increasingly in Asia. You need government ID just to activate any SIM card. The whole concept of a burner phone becomes meaningless when the government has your passport number tied to every device you activate. One particularly sobering comment talked about OPSEC, operational security, and how hard it really is. They pointed out that if you're serious about using a burner phone, you can never, ever log into your regular accounts on it. No checking your Gmail just once, no logging into social media to see what's happening. The moment you do that, you've created a link between your burner identity and your real one. And most people, they just can't maintain that level of discipline. There was also discussion about a service called PGPP that used to let you rotate your IMEI, that's like your phone's fingerprint, but it's shut down. And tools like Graphene OS, which is a privacy-focused Android variant, well, they're great, but they're not magic. You're still connecting to cell towers that track your location by design. What struck me most about this whole discussion is the gap between what people think burner phones can do and what they actually provide. In the movies, you snap a flip phone in half and disappear into the crowd. In reality, you're carrying a device that's constantly screaming, "I'm here," to every tower in range, and those towers are keeping logs. The workshop's secret goals, and I love that they called them secret goals, included helping people understand these limitations. It's not about giving people false confidence, it's about harm reduction. Maybe you can't be completely anonymous, but you can make tracking harder. Maybe you can't disappear entirely, but you can reduce your digital footprint. You know what this really reminds me of? It's like teaching people to lock their doors. A determined thief can still break in, but most threats are opportunistic. A burner phone won't protect you from the NSA, but it might protect you from your stalker ex who's been tracking your location through that fitness app you forgot you shared with them 2 years ago. And that's a wrap on today's top stories from Hacker News. What a journey we've been on, from German ISPs blocking websites that document their censorship, to AI browsers that could literally drain your bank account, to the promise and peril of AI coding assistants that can speed up development by 36x, but might also be automating us out of jobs. And finally, the sobering reality that true digital privacy might be more illusion than reality in our connected world. What strikes me about all these stories is they're really about trust and control in the digital age. Who gets to decide what we can see online? Can we trust AI with access to our personal data? Are we building tools that empower us or replace us? And in a world of ubiquitous surveillance, is privacy even possible anymore?
These aren't just technical questions. They're fundamental questions about the kind of future we're building. And the fact that these were the top stories out of 28 that appeared on Hacker News yesterday tells us something important. The tech community is grappling with these issues in real time, and the answers aren't clear-cut. Tomorrow, we'll be back with another set of stories from the front lines of technology. Until then, keep questioning, keep building, and maybe check what DNS server you're using. This has been Hacker News Daily. Stay curious, folks.